All right, this is homework number 24. I've adjusted this assignment a little bit, so I moved some of the first few problems to assignment 23. So my list starts in a different place than maybe your homework assignment list, so just be aware of that. So starting with number 25, find the interval of convergence of the power series. Be sure to check the endpoints, unless you're doing geometric series, which I don't think any of these are. If you're using ratio test, you need to check the endpoints. All right, so for this first one, even though I could write these both to the n minus 1, if they're not both to the n, I prefer to do ratio test because I'm not quite sure if geometric, I haven't thought enough about this, whether geometric works if it's to the n minus 1. Oops, okay, so when I plug in n plus 1 into n minus 1, I get n, and then this will be 3 to the n. Multiply it by 3 to the n minus 1 over x minus 3 to the n minus 1. We had one similar to this on the previous assignment. I think these were c minus 1s maybe. All right, so what will we have left? So remember, when you're doing this, you are subtracting your exponents. So this would be n minus the quantity n minus 1. So that's going to leave you with x minus 3 to the first. And then on the 3's, you're going to get n minus 1 minus n. So that's going to leave you with 3 to the negative 1. So I'm going to rewrite this just so it's clear what I have left. So there's an x minus 3 to the first, so an x minus 3 on top, and a 3 to the negative 1, so a 3 to the first on the bottom. And there is no n left in this problem, so as n approaches infinity, this just remains x minus 3 over 3. And this series converges by the ratio test. If the absolute value of x minus 3 over 3 remains less than 1. And that means that this x minus 3 over 3 needs to stay between negative 1 and 1. We need to start solving for x, so I'm going to multiply the 3 over to both sides. And at this point, I know it didn't ask for this, but at this point, that shows me the radius of convergence is 3. We're 3 units from the center. From the x minus c expression, I should say. And then when I add 3 to both sides, I get 0 is less than x, which is less than 6. So again, this is the interval, but it is possible that at the endpoints, maybe this expression would converge. And even if you're kind of doing it in your head and checking and realizing that it will not, we should practice for the AP free response, where they will give us something where we need to kind of verify and show whether or not the ends are converging. So just do it, basically. X equals 0. If you practice this now, you will do it correctly for a free response, I guess is what I'm trying to say. Okay, so the series from 1 to infinity of, let's see, 0 minus 3. So that would be negative 3 to the n minus 1 over 3 to the n minus 1. And these are both to the n minus 1, so you can say that's the same as having negative 3 over 3 to the n minus 1. So I'm going to rewrite this one more time. So this is the same as having negative 1 to the n minus 1. And this series would diverge by the nth term test. Okay, so it's going to be similar for 6, but I'm going to show that anyway. So if x equals 6, we're doing the sum. And again, if you're going to bother writing all of this, if you want credit for it on a free response, do all the things. Don't just write a sigma, write n equals 1 to infinity. Do it formally. So if you put in 6 minus 3, you get 3 to the n minus 1 over 3 to the n minus 1. Well, that's just 1. It could be 1 to the n minus 1, I suppose, but it doesn't. That part doesn't matter. So this also diverges by nth term test. So we will not include either of the endpoints in our interval of convergence. So our final interval is just x between 0 and 6, but not including those ends. All right, let's take a look at this next one. So lots of factorials involved, so we definitely need ratio test to start our interval of convergence. So this is the limit as n approaches infinity of n plus 1 factorial times x to the n plus 1 over 2n plus 2 factorial, because you're plugging in like this. And then you're multiplying that by 2n factorial over n factorial times x to the n. So there is a lot that's going to cancel out here. Remember, n plus 1 factorial is n plus 1 times n factorial. So the n factorials can cancel. 2n plus 2 factorial is like 2n plus 2 times 2n plus 1 times 2n factorial. So those are going to cancel. We know that x to the n cancels with x to the n plus 1 to leave us with x to the first. So I want to clean this up for whoever is grading my paper so that they can clearly see what I have left and so that I don't mess something up by leaving something out. So I'm writing everything that's left. I've got n plus 1 times x in the numerator and 2n plus 2 times 2n plus 1 in the denominator. This is a degree 1 over a degree 2. It's bottom heavy. So this limit is coming out to 0. And 0 is always less than 1. So this series converges by the ratio test for all x. So what is the interval of convergence? It's anything from negative infinity to infinity. You can plug in anything you want for x, is what this is saying, and you'll get a finite sum. Okay, number 34. Here's one of these again. Just a reminder, this is not a factorial. This is saying you're going to multiply all of the odd integers until you get up to whatever your value is when you plug n in. So it's sort of factorial adjacent, but not a factorial. All right, so let's do our ratio test for this one. I'm just going to put this down here where I have room. So this is going to be n plus 1 factorial. This will be x plus 1 to the n plus 1. When you plug in n plus 1 into 2n minus 1, you get 2n plus 2 minus 1, so you get 2n plus 1. All right, so down here, we would still have 1 times 3 times 5, and you would have a 2n minus 1, and then after that, you'd have a 2n plus 1, because you're adding 2 every time, right, to get to the next one. So if you add 2 to get to this, you would have the previous number there. You don't have to show this. I just like to so that I can see what's canceling out. All right, and then multiply by the reciprocal of the nth term here. And we're looking at what's canceling. So 1 times 3 times 5, all of that will cancel. The 2n minus 1 will cancel here. So we'll just be left with 2n plus 1. N factorial cancels with n plus 1 factorial and just leaves you with n plus 1. And x plus 1 to the n cancels with x plus 1 to the n plus 1, leaves you with x plus 1 to the first. So again, I will rewrite what I have left just to make things nice and neat and clear, because a bunch of slashing and crossing out is not ideal for an AP grader checking my work or your teacher checking your work. Oops. All right, so we have a tie. We have degree 1 over degree 1. So this is coming out to 1 over 2 times x, absolute value of x over 2, basically. And so this series converges by ratio test if the absolute value of x over 2 is less than 1. That means, now you can skip, by the way, to this step right here if you want to. I'm just, for consistency's sake, I'm just trying to keep doing the same thing over and over. So that means that x over 2 can be between negative 1 and positive 1. That means that x can be between negative 2 and positive 2. By the way, our radius of convergence is 2. Back here, by the way, the radius of convergence was infinity. And then we need to check these endpoints. So I'm going to check the endpoints and plug in what I have here. All right, so if x equals -2, then what does this original series become? So we've got the series from 1 to infinity of n factorial. -2 plus 1 would be -1 to the n, so it's something alternating. 1 times 3 times 5, times 2n minus 1. All right, so what about this one? I think that you would just do the ratio test on this, because my gut is to say like, oh, won't this factorial grow faster than just multiplying the odds? But it is alternating, and I think we should double check a ratio test, because that would have been my thought back here, right? But we just showed that this does converge sometimes. So let's go ahead and check this. All right, so if we do a ratio test on this one, the limit as n approaches infinity of n plus 1 factorial, we're ignoring the negative part because we're an absolute value, over 1 times 3 times 5. We just said this would be like 2n minus 1 times 2n plus 1, if we plug a plus 1 in there. And then times 1 times 3 times 5, times 2n minus 1. I know this is kind of repetitive, I know, because we just did almost the same thing, just without the x's. So, which is the other reason why I was just saying, like, we should probably do ratio test, unless it's a really obvious nth term test. If factorials are involved, it's a good idea to ratio. N factorial and n plus 1 factorial cancel to n plus 1. So we're left with just the limit as n approaches infinity of, just n plus 1 over 2n plus 1. And that's 1/2. And remember, the ratio test in general says as long as you get something less than 1, then this series converges. So converges by ratio test. So we are going to include the endpoint of -2. And then let's check to see what happens at 2. Now, actually, I don't think I have to do the work again for this, because what's going to happen when I plug in 2? I'm going to get n factorial times 1. Oh, no, wait. Sorry, it's not the same thing. I was thinking I would get 1 to the n, but actually, when I plug in 1, I get 3 to the n. So that's a little different. Over 1 times 3 times 5, times 2n minus 1. I am again going to do a ratio test to see what's going on here, because maybe with this exponential thrown into the top, maybe it'll diverge now. So the limit as n approaches infinity of n plus 1 factorial times 3 to the n plus 1 over 1 times 3 times 5, 2n minus 1, 2n plus 1, times 1 times 3 times 5, 2n minus 1, over n factorial 3 to the n. All right, so all this good stuff cancels out. We still have this 2n plus 1. N factorial and n plus 1 factorial leave us with n plus 1. 3 to the n plus 1 means we've got a 3 to the first. So cleaning it up a bit, I've got n plus 1 times 3 over 2n plus 1. So this is still a tie. It's 3n over 2n, so it's 3 over 2. But 3 over 2 is bigger than 1. So this series diverges by the ratio test. Remember what we said with ratio tests? It's kind of like it's acting like a geometric series where the common ratio is 3 over 2. So that thing would just keep growing. All right, so this one, we are including -2. X is greater than or equal to -2. We are excluding +2. All right, let's take a look at 37. Find the interval of convergence of the power series. Be sure to check the endpoints. Okay, so this one is just sort of generic. This looks like a geometric series, so I'm not going to do ratio test. I'm going to say I know that this converges by geometric series test if the absolute value of x over k stays greater than 1. And I'm not going to have to check the endpoints because with the geometric series test, you don't include the endpoints. Because if this equals 1 or -1, you get 1 to the n or -1 to the n. So I'll skip right to saying -1 is less than x over k, which is less than 1. Negative k is less than x, which is less than k. By the way, r is k. Back here, oh, I already said that r was 2. Okay, anyway. And then there is one more thing, though. This would be my answer, except it does say that k has to stay greater than 0. So I need to adjust that and say, okay, not negative k. X can be anything between 0 and positive k. And again, I'm not checking endpoints because with geometric series test, a true geometric series cannot be have a common ratio equal to 1 or -1. All right, let's take a look at this one. The limit, I'm going to do ratio test. As n approaches infinity of n plus 1 factorial times x minus c to the n plus 1 over 1 times 3 times 5 to the 2n minus 1, 2n plus 1 times 1 times 3 times 5, 2n minus 1 over n factorial x minus c to the n. Lots is canceling out. We keep seemingly having kind of the same types of things, so hopefully you're getting used to this. All right, so what is this limit coming out to? So the limit as n approaches infinity, so we have an n plus 1 times an x minus c over a 2n plus 1. So the n's will come out to 1/2 in the end. So this will be like absolute value of x minus c over 2. So this series converges by ratio test if absolute value of x minus c over 2 stays less than 1, which means that fraction can actually be between -1 and +1. We can multiply the 2 over. That means r is 2, by the way. Add the c over, so it would be like positive c minus 2 or positive c plus 2. And checking the endpoints here. Checking the endpoints is kind of weird on this one because you're plugging in like c minus 2. But if you check the endpoints, so let's say x is c minus 2. You have n factorial. C minus 2 minus c is just -2 to the n over 1 times 3 times 5, 2n minus 1. Okay, and what's happening with this one? I think I can say diverges by nth term test on this one, especially now that I've done this one here. Maybe if I hadn't done this, I would do ratio test again. So I could do ratio, but I'm kind of running out of time as well. So I'm going to say diverges. I'm going to say by nth term test, but that's a little bit flimsy. So maybe I should officially do ratio test, but I just am running out of time here. And then if I do x equals c plus 2, I should get kind of the same idea. That'll be n factorial, and then c plus 2 minus c will be 2 to the n over 1 times 3 times 5, 2n minus 1. So same thing. Same thing is happening here. These endpoints will not be included. It's going to be c minus 2 is less than x, which is less than c plus 2. Okay, I'm going to pause this video here, and I'll have to start a new one for the actual calculus part of this. So there's a second video coming for these last few problems.